All right, so I'm going to work out a few of these problems. I know that this is one of those topics that everybody's kind of in a different space and speed. And so, unfortunately, I can't run around to everybody sometimes. So I just kind of want to leave you with a video of a few examples that you can look and follow. And also, you'll be able to ask me questions. So the first thing we want to do is get our signs on one side. Now for this question, I'm going to subtract this one just because I'd rather stay away from negatives if I could. So let me go ahead and do that. So minus sine x on both sides. And again, the only reason I'm doing that is because that means that it's actually also saving me a step getting sine by itself, because this number will be on the other side. And so that will just be negative square root of 3 equals 2 sine x. So negative square root of 3 equals 2 sine x. And now what I want to do is get that sine by itself. So I'm going to divide by 2. And so now I've got sine x equals negative square root of 3 over 2. For the sake of time, I'm not going to give you the final answers on here, so you should be able to find those yourself. So as far as the actual, oh my goodness, I just broke this. Sorry about that. Let's try that again. So as far as finding what angles give you a sine value of negative square root of 3 over 2, I will let y'all figure that part out yourself. So remember, this is not the final answer. There's two answers to this question. So you got to write x equals. But I'm not going to do that part for you. All right. We have other ones. Sorry about that. We have other ones like number 6, where I got the secant by itself. Okay, so I've got secant by itself. I'm going to divide by 3 to get rid of that coefficient. That looks confusing. That does not look like a 3. So then I get secant squared x equals 4 over 3. And for the most part, you guys will see the square and you want to get rid of the square. You're like, okay, square root both sides. Perfect. But the part that y'all struggle with is actually knowing how to square root that. So this becomes secant x. And then the square root of 4 is 2. Right? So that's going to be 2 over, and then the square root of 3, which is just going to be the square root of 3. So this is a unit circle value. Actually, technically, this is positive and negative. Whenever you square root, you get a positive and a negative, though at this point, probably not going to take off too much points if you forget that negative answer. So you want basically all of the angles that have either positive 2 over the square root of 3 or negative 2 over the square root of 3 for secant. And that's going to be 4 answers. So for this one, for number 6, you're going to have 4 answers. Okay. And tomorrow I'm going to pass out in beautiful unit circle value tables that you'll get to use that are typed up, so you won't have to try to read your crappy handwriting anymore. And it has all the versions of the fractions. Okay, so there's that. Let me kind of help you out through a couple more. So like number 8, and I literally put on here, factoring out the greatest common factor. For this whole page, that is the theme of the whole page, is factoring out the greatest common factor to solve. So for number 8, I want to factor out, what do they have in common? What do they have in common? Okay, so they both have cosecants. This one is cosecant squared, that one's cosecant to the 4th. So I'm going to factor out a cosecant squared. And then the first term, if I divide out a cosecant squared, that's going to be cosecant squared. Because remember, if you multiply it back in, that's going to be cosecant to the 4th. Minus my second term, which is just going to be 4. So remember, this should always work out to where if you multiplied it back in, then it would give you what you started with. And the reason that I was able to do this was because it was equal to 0. So remember, sometimes you will have to set it equal to 0 yourself. So now I write my two equations. Each of these factors equals 0. Cosecant squared x equals 0. And cosecant squared x minus 4 equals 0. So I just take each of those factors and set them equal to 0 because 0 times anything is 0. From there, the square root of, or I square root both sides. So that's cosecant equals, the square root of 0 is positive and negative 0. So you want to find when cosecant is 0. And that, I believe, will give you two answers. I think that is 0 and 180. I'm pretty sure. Maybe. Maybe not. And then for the other one, I want to add 4 to both sides. Cosecant squared x equals 4. Then the same thing, I square root both sides. So square root, cosecant squared x equals positive and negative 2. So you need all the angles that give you cosecant is positive 2 or cosecant is negative 2. So for number 8, you might even have 6 answers, I believe. You might have 6 answers. All right. What else we got here that'll be helpful for me to do? So let's look at number 10 then. Number 10 has an extra step at the beginning that number 8 does not have, right? So for number 10, it's not already set equal to 0. I've got to get it set equal to 0. So I want to do minus cosine first. So I'm going to subtract cosine. And very important, a lot of y'all have a bad habit here. You're going to see this and you're going to be like, oh yeah, combine like terms. And it's good to try to think of that, but these are not the same. This one is a cosine squared and that one is a cosine. So they are apples and oranges. We can't put them together. So 2 cosine squared x minus cosine x equals 0. And now this looks very similar to problem number 8. Now I can factor and solve. So I'm going to factor cosine out because they both have a cosine in common. So cosine x, 2 cosine x minus 1. Right? Because if I multiply it back in, that's going to give me the same thing I started with. Set each of those factors equal to 0. Cosine x equals 0. 2 cosine x minus 1 equals 0. So the answer here is going to be whenever cosine is 0, that's going to be at 90 and 270, or pi over 2, 3 pi over 2. And then here we want to get cosine by itself, so that one's not ready. I'm going to add 1 and then divide by 2. Okay, so I'm going to kind of skip the work a little bit. Add 1, divide by 2, that's going to give me 1/2. So then the other answers will be when is cosine 1/2, and that is at pi over 3 or 60 degrees, and then something in the fourth quadrant. All right, now let's make them even worse-ish. Let's look at, let's say 13, actually. So looking at 13, we have a couple different options there. So some of y'all might want to use identities and stuff like that, but on this one it's actually not really helpful. So I actually just want to set this equal to 0 first. That's going to be the easiest way to go about that. So again, it's a subtracting tangent from both sides, and they're not like terms because this one has a secant next to it. So it's going to be tangent x secant x minus tangent x equals 0. Okay, so there's that, and now I just want to divide out a tangent. I want to factor out a tangent. Now it's important that you don't just say like, oh, I'll divide both sides by tangent. Bam, bam, those cancel out. Because even though that does seem to work, it actually gets rid of one of your answers, and that's kind of one of the problems there. So we don't want to do that, okay? Because it will get rid of one of our answers there. So we got secant x minus 1. Okay. Again, if we multiplied it back in, we would end up with what we started with. So now each of those equals 0. Tangent x equals 0. Secant x minus 1 equals 0. And then you want to solve both of those. Okay, so whatever gives you tangent is 0, and whatever gives you secant is positive 1. All right, let me try to work some from the final page. Okay, this is where it gets as good as it gets. Okay, let's start off with something you're more familiar with. So let's actually start off with like number 15. Again, we want to ignore the secant and maybe rewrite this as I don't know, like let's say y. So y squared minus y minus 2 equals 0. And so this becomes one of those things that we did last year where we had to factor. Our quadratic has nothing in the front, so we can go ahead and just write y and y right there. And all I need to make this work is two factors of negative 2 that add up to negative 1. That's going to be negative 2 and positive 1. Because again, they multiply to make negative 2, but they add up to negative 1, which is that coefficient right there. And then from there, we can translate it back. So this y plus 1 is really secant plus 1. So that means that secant x plus 1 equals 0, because we said each of these factors equals 0. And then this one means that secant x minus 2 equals 0. Okay, so I kind of did two things there at the same time. I set each factor equal to 0, but I also retranslated it back to secant, which is very, very useful. Okay, and then we get secant by itself and solve. So when does secant equal negative 1? When does secant equal positive 2? Okay, before I run out of time, this is actually the hardest one. So save the best for last, number 14. Okay, first thing is it's not equal to 0. Okay, this is factoring. Okay, these are all going to be the big parentheses factor. Okay, not just greatest common factor, but the two pairs. So I want to move that 3 over. So that's going to be 2 sine squared x minus 5 sine x minus 3 equals 0. And then it would help to rewrite it in another letter. So again, I'm just going to use y. So that's 2 2y squared minus 5y minus 3 equals 0. And again, this is just to make it look neater. Makes it a little bit easier for you. This one's different. There's a 2 in the front of the y squared. But that's okay because we know that the only factors of positive 2 that we would want to use here are going to be 2 and 1. So I'm going to write 2y and y. So the only thing I have to be careful of here is that whatever term I put over here is going to get multiplied by the 2y. So whatever factor of negative 3 goes right here is going to be doubled. Okay, so my factors of negative 3, are going to be 1 and negative 3, negative 1 and 3, and that's it. Okay, those are my only options. So those are the only two pairs that I'm going to be filling in here. So let's think about it. If I put a positive 1 here, that's going to be 2 times 1, so that's 2. And then over here is going to be my negative 3. So when I add them up, it's going to be negative 3, positive 2, and that's going to add up to just negative 1. So that's not going to work. So it has to be the other combination. It's going to have to be negative 3 going here and positive 1 going here. And it makes sense. 2 times negative 3 is negative 6. That's positive 1. So when those add up, it's going to be negative 5. So let's write down each of these equal to 0. And let's translate it. So 2 sine x plus 1 equals 0. 2 sine, or sorry, not 2. That was just sine x minus 3 equals 0. And you're going to solve those. Alright, y'all. I'll see you in class tomorrow. But again, if I can't help you, this is probably the best place to look. Alright, to get some help.